So let's take a look at subtracting polynomials. So for this, we're going to work with the definition of subtraction, which is really just adding the opposite, right? So if we think about 5 minus 7, this is really just 5 plus -7, right? And we can rewrite it that way. So we want to go ahead and do this. And the shorthand way is we're going to change it to an addition problem. So we're going to be adding two polynomials, which means we need to take the opposite of the entire second polynomial. And I mean the entire thing, every single term. So we're going to change the signs of the second polynomials. That's the adding the opposite part, right? So we're going to go ahead and take this first problem and we're going to change it to an addition problem. So we are going to take 9x squared plus 5x plus 8, and then instead of subtracting that polynomial, we're going to add the opposite. So everything becomes the opposite. Positive becomes negative, negative becomes positive. So we're going to have a negative 6x squared minus 9x plus 3. So everything became the opposite there in the second polynomial. So we're adding the opposite. And now it's just an addition problem. Combine like terms. 9 plus -6 is 3. So we have 3x squared for our first term. 5 plus -9 is -4, so minus 4x for our second term. And 8 plus 3. So it's a positive 11, so we have plus 11. Just double check that it's in standard form. So if I look at my exponents, I go 2, 1, 0, so that's decreasing, so we're good. So subtraction is really just an addition problem that we have to manipulate a little bit. Let's do a couple more. All right, so I'm going to change this to adding the opposite. First one stays the same, 8x cubed plus 5x minus 6. And now we're going to add and take the opposite. Positive 5 turns into a -5. Minus 8x turns into plus 8x. Plus 10 turns into minus 10. All right, so you just want to be careful. Make sure you're taking the opposite of absolutely everything in the last one, not just the first term. Now it's just an addition problem, so let's combine like terms. We have an x cubed. That's the only x cubed, so it stays the same. It's not combining with anything. And I always just do this in decreasing order of exponents of degree so that my final answer is already in standard form. So next up, we would look for any squared terms. We have a negative 5x squared. There are no other terms to combine that with, so I'm just going to go ahead and carry that on down. Then we have our linear terms. So 5 plus 8, we have two of them. So that's going to be a plus 13x. And then last but not least, we have our constants. So -6 plus -10 is a -16. So we're going to write minus 16 there for our final answer. Again, check in standard form, 3, 2, 1, 0. So we're good. All right, last problem. So the only difference here is that we have multiple variables per term, but we still want to just change this to adding the opposite. All right, so we have 8x squared y plus 3xy minus 9 plus, take the opposite, -3xy squared minus 5x squared y plus 2xy. So take the opposite of everything. Now we're going to combine like terms. So let's look for any x squared y terms. We have two of them. 8 plus -5 is 3, so we'll have 3x squared y. And then we're going to look for any more third degree terms, and we have one right there, but it doesn't have anything to combine to, so we're just going to carry it down just as it is. So minus 3xy squared. Then we have a couple xy terms here, so 3 plus 2 is 5, so we're going to have 5xy. And then we have a lonely constant term there, minus 9, and we're all done. So taking a look at these three problems, boiled down to just turning them into addition problems so that we could do something that we're already familiar with.